how to solve an equation, I think you could get them right. Some of them. All of them would be a stretch. But I did outline these steps. I will come back and touch on those once we see one of these in place. But if you are solving for any x, right, the idea is to isolate that x, get it all by itself. So what's the first thing over here, Angie, your gut tells you we should get rid of? The negative 4 by adding 4 to both sides. Nice job. How about next, Jack B? Before we get rid of the square root, what else is over there that we need to get rid of? The 3. We're going to divide that 3 away. And so what we've done now is completed step 1, isolate the radical. You get the radical all by itself first. You can't do anything underneath that radical. Not that there's anything to do here within the radical, but sometimes there will be. You can't do anything underneath the radical. Consider that like prison. Okay? You can't touch anything in there until you free it from a radical. And a radical is taking the square root. Yes? So what is the opposite operation of the square root? Chris? Squaring. Squaring will undo the square root. So I'm going to square both sides, and I get x equals 64. Now, linears, quadratics, absolute values didn't have this feature. But sometimes, with more advanced functions, you'll have solved it completely properly, and yet that answer won't work. Sometimes. Okay? So this is a little bit different than what you're used to in Algebra 1, is we're going to check the answer in the original, not as much for accuracy anymore, because we'll just assume we do things accurately anyway, but more for what sometimes can come up, which is a type of solution. We will run into it today, but I'll save you the vocab word until we actually get there. So if I go back and plug in 64 and follow order of operations on the left-hand side, the square root of 64 is, everybody, 8. 3 times 8 is, and 24 minus 4 is 20. So that actually does check out. So that is the solution. So you isolate the radical, you square both sides, and for this one, that was enough, because this was a very, very simple one. Okay? In the next example, our radical is already isolated, yes? The radical, there's a bunch of stuff under the radical, but it is already isolated. Do we agree? There's nothing prior to the radical or after the radical that we need to get rid of. It just says that this radical equals x minus 3. So step 1 is done. Step 2, squaring both sides, is going to be a little bit trickier than it was before. Why? Who can tell me and foresee why it's going to be trickier? Lucas?
You're going to have x squared.
Correct. Because when we squared both sides over here, it was just an 8, so it just became a 64. Now when we square this right-hand side, there's an x involved. That's number 1. And not only that, it's not just a single term, it's 2 terms, right? Do we square each of them individually? I'll answer that for you. No, right? This is a binomial. When you square a binomial, first of all, I would lock that up in parentheses.
I just wanted to wish you a happy Mean Girls Day. I remember that you said you loved the movie and it's October 3rd. That's all. Bye, and good class, you class.
Bye. I don't think I love that movie. I think he's confusing me. Anyway. Oh, no, because we watched a clip like The Limit Does Not Exist. Is that movie?
Yeah, is that bad?
Yes, see, clearly I don't love the movie. I barely know. That's why he's saying that. Okay. Happy Mean Girls Day, everybody. I didn't know. Yeah. So when we square both sides, those parentheses weren't originally there because they didn't need to be, quite frankly. But now that we know we're going to square it, I would definitely recommend throwing some parentheses around that so you remember to square the binomial properly the way we should. On the left-hand side, squaring is nice and easy. A square root and a square are just going to cancel. You don't have to do much work there. On the right-hand side, if you need to, you can put an x minus 3 and an x minus 3 right next to each other and go through your foiling process. Oops. If you feel like you've got this kind of shortcut and you can visualize this on your own, I hope eventually we can all get there. This is going to turn into x squared minus 6x plus 9. And so back to Lucas's point, yes, this is an issue because there's an x squared. Do we follow? So now I'm going to, do you remember, now we're going to have to review quickly quadratics. How do you solve a quadratic? Bella?
You would have to subtract over the 2x, and then you have to add the 3 over, and then you have to like tee it up, and then
Yep.
find like which one.
Look at that. I can't tee it up. You missed one key word. I can't tee it up until I start. What do you have to do before you tee it up? Or what do you mean? Can you show me, tell me visually what you mean? Or like just tell me what to write down?
Well, you have to find which number adds 8 and multiplies 12.
And that process is called factoring? Yes? So we would kind of set up our parentheses because factoring is, in this context anyway, is like kind of figuring out that reverse FOIL process. So what times what would have given me x squared? We only have one option, right? X times x. And then what times what is going to give me positive 12? We have a boatload of options there, yes? 1 and 12, 2 and 6, 3 and 4. Or negative 1 and negative 12, negative 2 and negative 6, negative 3 and negative 4. The key is whatever I choose there, when I do my outer and my inner, it's got to add to negative 8. Chloe, what is it?
Negative 6, negative 2.
Negative 6, negative 2. This is where teeing it up comes in. And so when you tee this up, teeing it up technically means set each piece equal to 0. Oops. Now these are fairly easy ones where a lot of you would probably do this in your head. X either equals 6 or x equals 2. And again, back to the original to check. Starting with 6. If I plug a 6 in on the left, I get 12 minus 3, which is 9, and the square root of 9 is 3. If I plug 6 in on the right, 6 minus 3 is 3. So that checks out. 2. If I plug in 2 on the left, 2 times 2 is 4. 4 minus 3 is, and the square root of 1 is 1. On the right-hand side, if I plug in 2, what's 2 minus 3? Negative 1. Does that work? So there you see your first example of what we will be calling, what is called in math, an extraneous solution. So that's a vocab word you need to know. It's like extra, N-E-O-U-S, extraneous. Think about that, extra. It's like an extra solution that came up that doesn't actually work. Okay? And that's just because of the mechanics that happen within that squaring both sides process. Any questions on that? Okay? On part C, this gets a little bit, the plot thickens, right? The plot thickens because I have 2 radicals in the problem. Still, I'm going to start with isolating one of them, and it doesn't really matter which one you start with. Here, I think it makes sense to isolate this one first, frankly, because it's just done already. Yes? So I have this one isolated. This one's going to be a little bit long. So just give yourself a nice little border here. I should probably space these out more. So isolate radical, already done on the right-hand side. Are we done at 50 or 05? Okay, good. Step 2, square both sides. Now, when I square the radical alone side, we're good. When I square the left-hand side, that's a binomial, you guys. That's a radical plus a 4. That's 2 terms. That's a binomial. That needs to be squared using the FOIL method, which is going to be pretty long and ugly. This one, because it isn't as straightforward as squaring this binomial was, I'm definitely going to write this one out. Root 6x minus 11 plus 4 times root 6x minus 11 plus 4. Now, so when I start my foiling process, root 6x minus 11 times root 6x minus 11. What's going to happen to that, do you think, Owen? Right. Yep. So it's just going to be 6x minus 11, right? It's like root 5 times root 5 is just 5. Root 6x minus 11 times root 6x minus 11 is just 6x minus 11. Here's where it's going to get a little bit tricky. 4 times root 6x minus 11 is just that. It's 4 root 6x minus 11. And then when I continue my foiling, I have another 4 times root 6x minus 11. So I add 4 more root 6x's minus 11. And then 4 times 4 is 16. I'm still working on the left-hand side right now. When I combine like terms here, I have a 6x. I have negative 11 plus 16, which will be a plus 5. And 4 of these radicals plus 4 more of these radicals is how many of these radicals? 8. So just plus 8 of these root 6x minus 11s. So that's what happens with my left side, and that's absolutely the complex part of this. On the right-hand side, life is all good because the radical and the squared will just cancel, so this just equals 12x plus 1. So foiling out that binomial that contains a radical is a challenge that you should definitely take your time on. Okay? If you jump to step 3, and now what I say here in parentheses will make sense, once we squared both sides in the previous 2 examples, we could just then solve the rest of the equation. Here we didn't have to do much. Here we had to solve a quadratic. Here, we can't solve for x because there's still a radical in there. So if there's still a radical, we pretty much need to start over. Which means, but here's the win. We started with 2 radicals in the problem. At least now we've got it down to only 1 radical. Are you with me? So start the process over. We have to isolate that radical, which means we're going to subtract our 6x over and subtract our 5 over. So we have 8 times the radical equals 6x minus 4. Now, here's a second. I should really switch these 2 examples around, C and D, because what we run into right now is what we would also we will be talking about in D as well. If I want to truly isolate this radical, I have to divide by 8. Yes, on both sides. What do you foresee being an issue if I divide both sides by 8? Chris? Fractions. And we don't really want to have to deal with fractions. So, because especially when you go to square both sides, you'd be squaring a binomial that contains a fraction, and that's not pretty. So, it made sense over here to divide by 3 because it divided nicely. Didn't have to worry about it. If it doesn't divide nicely, you don't have to divide it. We can square both sides right here. The issue is, on the left, just be careful of this. You have to square the 8. What's 8 squared? 64. And you have to square the radical, which is just going to leave it 6x minus 11, right? It's going to be 64 times 6x minus 11. Because technically, you guys know this, there's multiplication in between the 8 and the radical. It's just like if it was 8x, that's technically 8 times x. 8 root is technically 8 times the root. So when I do this, it's going to be 64 times 6x minus 11, and 6x minus 11 is a binomial, so we need to make sure we keep that in parentheses, because that 64 will have to be distributed. On the right-hand side, again, we're squaring a binomial. You're going to get 36x squared minus 24x twice, which will turn into minus 48x, and then plus 16. So not pretty, but it's a quadratic again because the x squared, so I have to distribute my 64. I'm cheating. 64 times 6. It's 384x minus 64 times 11 is 704. We're not going to complete this one all the way, but we're kind of ironing out this and getting it down to a quadratic. So I'm going to do the whole quadratic concept that Bella talked about earlier, getting everything equal to 0. Subtract your 384x over. Add your 704 over. And we would be solving this. Minus 432x plus 720. Now, does anybody in their right mind want to factor something like that? Is there any number that divides out of all three of those that could make life easier? A 36. So if I divide both sides by 36, that'll just change it to x squared minus 12x plus 20. Now I'm less fearful. Anytime you see that with all of your coefficients, you can definitely do that. And this factors into x and x for sure. What are our two numbers that'll give us 20, but will combine to negative 12? Chloe? Tell me about my signs. Plus 10 and both negative. Minus 10. Minus 2. And Chloe, tell everybody how you know they're both negative.
Oh, the plus sign is just like the same, means the same, and then the negative tells you which.
Right. Anytime your trinomial ends with a plus 20, if they have to multiply to get a positive number, they either both have to be negative, because a negative times a negative will give you a positive, or they both have to be positive. And you look at your middle sign to dictate what that is. So double negative here. Did you know that? I know different teachers teach it differently. So when we tee it up, we're going to get two solutions. X equals 10 and x equals 2. And then you want to check those. So I'll just do this mentally. I'll check the 10 first. 6 times 10 is 60. Minus 11 is 49. Square root of 49 is 7. 7 plus 4 is 11 on the left. 10 on the right. 12 times 10 is 120. 120 plus 1 is 121, and the square root of 121 is 11. So 10 works. Let's check 2. 6 times 2 is 12. Right? 6 times 2 is 12. 12 minus 11 is 1. Square root of 1 is 1. 1 plus 4 is 5. On the right-hand side, 12 times 2 is 24. 24 plus 1 is, square root of 25 is 5. Life is good. They both work. That was a doozy, ladies and gentlemen. That was a doozy. You know what we could have done to avoid those huge numbers? I didn't want to divide by 8, but I still could have divided both sides by 2. Because that would have become a smaller 4. That would become a smaller 3. And that would become a smaller 2. That would have helped earlier on if I wanted to avoid numbers. But, okay? Any questions? So we don't really need to talk about D now because my point was just going to be to square both sides right away, which would make it 4 times x plus 3 equals 25. And then this one's pretty easy to solve. So not dividing by the coefficient if it's going to create a crazy fraction, and knowing how to keep it there yet properly square it. Okay. That was those. You're going to want to go watch that video again when you get to a problem like this on your homework. All right. Down below, we have a system of equations. Now, I said when we do systems in 3 variables, we're always going to do elimination. In a case like this, when it's a system involving a linear, which I'm pretty positive will never be different than that. It's always going to be a linear with some other type of function, whether that's a quadratic or a radical or an exponential. Once we learn those, it'll be a linear with something else. You should be doing substitution when they want algebraically. So, first thing we're going to do is solve this graphically. Now, obviously, you could cheat and just type it into your calculator, but we should also be able to do this by hand. So, a y-intercept of 1 and a slope of 1 gives us a line that looks like this. And then the radical function is the parent graph shifted how? Vince? Because they added the 3, I've already told you it's a shift. I need you to tell me, is it horizontal or vertical? And which direction? Left. Left 3. So our endpoint of the parent graph is usually at 0, 0, and it goes off like this. But now we're shifting that 3 units to the left. 1, 2, 3. So there will be one term. There will be the second. It might get a little fuzzy from here. There's the next one. Going to look like this. And so visually you can see your solution is at 1, 2. On a graph, just to review, if we want to know where that point of intersection occurs, second trace. It's our favorite menu, and option 5, intersect. Select the first curve, that's the radical, because that was the first one I plugged into the calculator. Then I hit enter, and it jumps to the second curve, that's the line, because that's the second one I plugged in. Then it's going to say guess, you just hit an enter through that, and it will put you right at 1, 2. Okay? So calculator should work there. Algebraically, this is going to be substitution. So if y equals this and y equals that, what does substitution tell you you can do? If both of those expressions equal y, then they must, Lucas, equal each other. So the square root of x plus 3 equals x plus 1. And we solve. Isolate the radical, done. Square both sides. Done. Solve that quadratic. So that's getting it equal to 0. Factoring. What are the two numbers going to be here? Sierra? -1 and +2. Very good. So my outer is 2x and my inner is -1. 2 minus 1 gives you that 1. So your two answers are x equals 1 and x equals -2. Now for a system, your x solutions are not your only solutions. Yes? You want to give the point. So you're solving a system, you're solving for both variables. So if you know x is 1, then you go back and you plug in an x of 1 to figure out the corresponding y. 1 plus 1 is 2. So there's one solution. And if you plug in -2, -2 plus 1 is -1, would be the corresponding y there. Why did we get two solutions algebraically, but only one solution graphically? Goes back to that extraneous, okay? -2, -1 is a point that, yeah, works for the line, but -2, -1 does not work for the radical. That we reject. Truthfully, if we gave this radical the bottom side of it, that second point is where it would have crossed. But that radical is got to be a function, so it's not going to wrap back around. All right? So, on your homework, I think we got to chop this down a little bit. I want you guys to do on your when you get this, I want you to do just this section here. So it's only number 1 essentially, but it goes A, C, 14, D, F, 16. So it's a little bit weird, but just this section here is all I want you to do for homework. Is that clear? So 3, 6, 9, 12 of these. Did I send you a reminder about your next test or quiz? I did? Or no? Okay, so because I'm going to spend an extra day on this, that's going to push back a day. No. Remember I got smart? Send them that way. This is your column.